So generally aerobic respiration completed in 4 steps. First one is what is the first step? Glycolysis. Second one, oxidative decarboxylation of pyruvate, Krebs cycle and electron transport system. So first starts with glycolysis. This glycolysis is discovered by the scientist, 3 German scientists. Who is that? Emden, Mayer of Paris. Emden, Mayer of Paris. That's why only glycolysis is called as EMP pathway. Glycolysis takes place in cytoplasm. That's why only it is called as cytoplasmic respiration. And it is the common pathway in both aerobic and anaerobic respiration. In case of glycolysis, 1 molecule of glucose is converted into 2 molecules of pyruvic acid. How we will see? See, in case of so in case of glycolysis starts with what? Glucose. This glucose is converted into what? Glucose 6-phosphate in the presence of hexokinase enzyme. In the presence of hexokinase enzyme, glucose is converted into glucose 6-phosphate. ఇక్కడ hexokinase enzyme ఏం చేస్తుంది అంటే ఇక్కడ చూడండి. What is that enzyme name? What is that enzyme name? Hexokinase. ఇక్కడ రాస్తే so this hexokinase enzyme removes one phosphate from ATP. It removes the phosphate from ATP. So automatically ATP is converted into ADP. Adenosine triphosphate లకి ఒక phosphate remove అయింది. అప్పుడు ఏమవుతుంది? Diphosphate అవుతుంది. That phosphate is added to glucose. That's why glucose is converted into glucose 6-phosphate. So what is the reaction? Hexokinase enzyme removes the phosphate from ATP. Result ATP converted into ADP. Here phosphate is added to glucose to form glucose 6-phosphate. So here ATP consumed or produced. In this reaction ATP consumed or produced? Consumed. How many ATP consumed? 1. Now what is the product, Nana? Glucose 6-phosphate. This glucose 6-phosphate in the presence of enzyme phosphoglucoisomerase enzyme. This glucose 6-phosphate in the presence of enzyme, in the presence of enzyme phosphoglucoisomerase, it is converted into its isomer fructose 6-phosphate. Isomers అంటే structurally similar. Isomers అంటే what is isomer? Structurally similar one is called as structurally similar one is called as isomer. Glucose fructose isomer. Like that, glucose 6-phosphate is isomer to the fructose 6-phosphate గా మనం చెప్తున్నాం. So in the presence of which enzyme? Phosphoglucoisomerase enzyme. Glucose 6-phosphate converted into its isomer, that is fructose 6-phosphate. See, here enzyme phosphofructo. Enzyme name ఏంటన్నా? phosphofructokinase enzyme. Phosphofructokinase enzyme removes the phosphate from ATP. Phosphofructokinase enzyme removes the phosphate from ATP. ATP is converted into ADP. The removed phosphate is added to fructose 6-phosphate. Result, it is converted into fructose 1,6-diphosphate. So in the presence of enzyme ఏంటమ్మా fructose 1,6 diphosphate bisphosphate both are same, di both are same. So that phosphofructokinase enzyme removes the phosphate from ATP. That phosphate is added to fructose 6-phosphate. Fructose 6-phosphate is converted into fructose 1,6. It is converted into fructose 1,6 bisphosphate or diphosphate. So this is the reaction. So in this reaction ATP consumed or produced? Consumed. Up to date how many ATP consumed? 2 ATP. In the first reaction 1 ATP. In third reaction is also 1 ATP. Up to date 2 ATPs are consumed. So which one is formed? Fructose 1,6 diphosphate. This is carbon number is also very very important. Glucose, how many carbon? 6. Glucose 6 phosphate, 6 carbon. Fructose 6 phosphate, 6 carbon. And fructose 1,6 diphosphate, 6 carbon. Okay na? So now which one is the present? Fructose 1,6 diphosphate is present. This fructose 1,6 diphosphate in the presence of aldolase enzyme. In the presence of which enzyme? Aldolase. So fructose 1,6 diphosphate in the presence of aldolase, it is split into 2 components, that is dihydroxyacetone phosphate, glyceraldehyde 3-phosphate. మొత్తం రాస్తున్నాను. Glyceraldehyde 3-phosphate. So fructose 1,6 diphosphate in the presence of aldolase enzyme, it is split into 2 simpler compounds, that is dihydroxyacetone phosphate, glyceraldehyde 3-phosphate. Dihydroxyacetone phosphate 3 carbon, glyceraldehyde 3-phosphate is also 3 carbon. అంటే 6 carbon containing fructose 1,6 diphosphate converted into 3 carbon containing dihydroxyacetone phosphate and 3 carbon containing what? Glyceraldehyde 3-phosphate. Clear? And see, listen, in case of enzyme glyceraldehyde 3-phosphate dehydrogenase enzyme. ఎంజైమ్ నేమ్ ఏంటినా? గ్లిజరాల్డిహైడ్ 3-phosphate. G3P అంటే గ్లిజరాల్డిహైడ్ 3-phosphate. గ్లిజరాల్డిహైడ్ 3-phosphate dehydrogenase enzyme. See, removes the hydrogens from glyceraldehyde 3-phosphate. Then it is converted into 1,3-diphosphoglyceric acid. It is converted into 1,3-diphosphoglyceric acid. That removed hydrogens accepted by NADP plus converted into NADPH2. కాకపోతే ఇక్కడ ఒక రియాక్షన్ చూడండి, DHAP అండ్ గ్లిజరాల్డిహైడ్ 3-phosphate both are isomers. సో అప్పుడు ఏమవుతుందంటే ఇన్ ద ప్రజెన్స్ ఆఫ్ ట్రయోస్ ఫాస్ఫేట్ ఐసోమరేజ్, ఇది బాగినండి, ఇన్ ద ప్రజెన్స్ ఆఫ్ విచ్ ఎంజైమ్? ట్రయోస్ ఫాస్ఫేట్ ఐసోమరేజ్ ఎంజైమ్. ట్రయోస్ ఫాస్ఫేట్ ఐసోమరేజ్ ఎంజైమ్ DHAP ఈజ్ ఆల్సో కన్వర్టెడ్ ఇంటూ గ్లిజరాల్డిహైడ్ 3-phosphate. ఈ రియాక్షన్ బాగినండి, మళ్ళీ ఇక్కడ కన్ఫ్యూజ్ అయితే న్యూమరికల్స్లో ప్రాబ్లం వస్తుంది. ఇక్కడ మనకేముంది నాన్న? Fructose 1,6 diphosphate in the presence of which one? Aldolase enzyme. It is split into 1 molecule of DHAP, 1 molecule of glyceraldehyde 3-phosphate. Now DHAP 3 carbon, glyceraldehyde 3 carbon, glyceraldehyde 3-phosphate also 3 carbon. ఇప్పుడు ఇవి ఎన్ని మాలిక్యూల్స్ ఉన్నాయి? హౌ మెనీ మాలిక్యూల్స్ ఆఫ్ G3P we have? 1 molecule. How many DHAPs we have? Only 1 molecule. Next what happens sir అంటే in the presence of dihydroxyacetone phosphate, in the presence of triose phosphate isomerase, in the presence of triose phosphate isomerase, DHAP is also converted into glyceraldehyde. ఆల్రెడీ ఒకటి ఉంది, నెక్స్ట్ ఏమవుతుంది? DHAP is also converted into glyceraldehyde 3-phosphate. అప్పుడు ఎన్ని మాలిక్యూల్స్ అవుతుంది? 2 molecules of glyceraldehyde 3-phosphate అవుతుంది. ఫస్ట్ ఫ్రక్టోజ్ 1,6 ఇవి చూడండి. ఫస్ట్ ఏమవుతుంది? ఫ్రక్టోజ్ 1,6 డైఫాస్ఫేట్ ఈజ్ కన్వర్టెడ్ ఇంటూ DHAP glyceraldehyde 3-phosphate. ఆల్రెడీ మనకు ఒకటి ఉంది. నెక్స్ట్ DHAP ఈజ్ ఆల్సో కన్వర్టెడ్ ఇంటూ glyceraldehyde. అప్పుడు ఇవి ఎన్ని మాలిక్యూల్స్ అవుతాయి? 2 మాలిక్యూల్స్గా మనకు. నౌ వీ హ్యావ్ హౌ మెనీ మాలిక్యూల్స్ ఆఫ్ glyceraldehyde 3-phosphate? 2 molecule. Next what happened? These 2 molecules of glyceraldehyde 3-phosphate in the presence of glyceraldehyde 3-phosphate, in the presence of enzyme ikkada rastunnanu, in the presence of glyceraldehyde 3-phosphate dehydrogenase enzyme, in the presence of glyceraldehyde 3-phosphate dehydrogenase enzyme, this enzyme removes the what? This enzyme removes the hydrogens from glyceraldehyde 3-phosphate. Result, it is converted into 1,3-diphosphoglyceric acid. 1,3-dipGA means 1,3-diphosphoglyceric acid form అవుతుంది. సి ఒకసారి ఇక్కడ చూడండి, ఇక్కడ 2 molecules కాబట్టి 2 NADP plus converted into 2 NADPH2. అప్పుడు 2 glyceraldehyde నుంచి ఎన్ని వస్తాయినా? 2 molecules of 1,3-dipGA ఏర్పడుతుంది. నెక్స్ట్ 1,3-dipGA నుంచి మనకేం ఏర్పడుతుందంటే PGA ఏర్పడుతుంది. 1,3-dipGA నుంచి PGA. సి ఎంజైమ్ నేమ్ చూడండి, ఫాస్ఫోగ్లిజరోకైనేస్. ఎంజైమ్ నేమ్ phosphoglycerokinase enzyme removes the phosphate from 1,3-diphosphoglyceric acid. That removed phosphate is accepted by ADP to form ATP. So 1,3-dipGA నుంచి 1-PGA పోయింది కాబట్టి ఏం ఏర్పడుతుంది? 3-PGA means 3-phosphoglyceric acid formation takes place. అర్థమవుతుందా? సో ఎన్ని ATPs ఏర్పడతాయి చెప్పండి ఇక్కడ? ఇన్ దిస్ రియాక్షన్ హౌ మెనీ ATPs ఆర్ ఫార్మ్? ఇక్కడ చూడండి బాగానండి. 1 molecule of 1,3-dipGA ఇఫ్ ఇట్ ఈస్ కన్వర్టెడ్ ఇంటూ 1 molecules of 3-PGA 1 ATP. కానీ మనకి ఎన్ని ఉన్నాయి? 2 ఉన్నాయి కాబట్టి ఇక్కడ ఏమవుతుంది? 2 ADP is converted into 2 ATP. 2 ATP is equal to 2 SLP నాన్న. సో SLP అంటే సబ్స్ట్రేట్ లెవెల్. SLP మీన్ వాట్ ఈజ్ SLP? సబ్స్ట్రేట్ లెవెల్ ఫాస్ఫోరిలేషన్ మీన్స్ సింథసిస్ ఆఫ్ ATP ఈజ్ కాల్డ్ యాజ్ సబ్స్ట్రేట్ లెవెల్ ఫాస్ఫోరిలేషన్. ఇక్కడ ఎన్ని ATPs ఏర్పడ్డాయి? 2 ATP. ఇక్కడ చూడండి 1 SLP ఈక్వల్ టు 1 ATP, 2 SLP ఈక్వల్ టు 2 ATP. సో ఇక్కడ ఎన్ని ATPs ఏర్పడ్డాయి? 2 ATP కాబట్టి హౌ మెనీ సబ్స్ట్రేట్ లెవెల్ ఫాస్ఫోరిలేషన్? 2 సబ్స్ట్రేట్ లెవెల్ ఫాస్ఫోరిలేషన్. ఇప్పుడు మనకి ఏం ఏర్పడింది? 3-PGA. హౌ మెనీ మాలిక్యూల్? 2 molecules ఆఫ్ ఎన్నైనా 3-PGA ఏర్పడింది. అవునా? నెక్స్ట్ ఇన్ ద ప్రజెన్స్ ఆఫ్, ఇగో ఇక్కడ రాస్తున్నాను, ఇన్ ద ప్రజెన్స్ ఆఫ్ మ్యూటేజ్ ఎంజైమ్, ఇన్ ద ప్రజెన్స్ 3-PGA అంటే అర్థమైంది నాన్న? ఫాస్ఫేట్ ప్రజెంటెడ్ 3rd carbon. ఇన్ ద ప్రజెన్స్ ఆఫ్ విచ్ ఎంజైమ్ నాన్న? ఇన్ ద ప్రజెన్స్ ఆఫ్ mutase enzyme. In the presence of mutase enzyme, 1 second, in the presence of mutase enzyme, this 3-PGA is converted into 2-PGA. 3-PGA is converted into 2-PGA. How many molecules of 2-PGA? 2 molecules. In the presence of mutase enzyme, 3-PGA, 2 molecules of 3-PGA converted into 2 molecules of ఏంటన్నా ఏ విధంగా మారుతుంది 2-PGAగా మారుతుంది. నెక్స్ట్ సి ఇన్ ద ప్రజెన్స్ ఆఫ్ ఇనలేజ్ ఎంజిమ్, ఇన్ ద ప్రజెన్స్ ఆఫ్ ఇనలేజ్ ఎంజిమ్ 2 ఏంటన్నా ఇట్ రిమూవ్స్ ది వాటర్ ఫ్రమ్ 2-PGA, result it is converted into phosphoenol pyruvic acid PEP అంటారు. సో 2-PGA is converted into 2 molecules of ఏంటన్నా phosphoenol pyruvic acid. ఇక్కడ ఎంజైమ్ ఏంటినన్నా ఇనలేజ్ ఎంజైమ్. వాట్ ఈస్ ద ఎంజైమ్ నేమ్? ఇనలేజ్ ఎంజైమ్. 1 second. So in the presence of inalase enzyme, in the presence of what nana? In the presence of inalase enzyme, it removes the water from 2-phosphoglyceric acid. It is converted into 2 molecules of phosphoenol pyruvic acid. And last reaction, phosphoenol pyruvic kinase. Phosphoenol pyruvic kinase enzyme. It removes the phosphate from phosphoenol pyruvic acid. Result, these 2 molecules of pyruvic acid, phosphoenol pyruvic acid is converted into 2 molecules of pyruvic acid. Edinana phosphoenol pyruvic kinase enzyme removes the phosphate from phosphoenol pyruvic acid. Result, 2 molecules of phosphoenol pyruvic acid is converted into 2 molecules of pyruvic acid. This removed phosphate is accepted by ADP. Result, it is accepted by ADP, not ATP. It is accepted by ADP to form ATP. మళ్ళీ ఎన్ని ATPs ఏర్పడే? 2 ATPs ఏర్పడే కాబట్టి it is equals to how many SLP? 2 SLP. 1 SLP equal to 1 substrate level phosphorylation. 1 substrate level phosphorylation is equals to 1 ATP. సో ఇక్కడ 2 ATPs ఏర్పడ్డాయి కాబట్టి ఇట్ ఈస్ ఈక్వల్ టు 2 SLPsగా మనము చెప్తున్నాం. సో టోటల్ హౌ మెనీ SLPs ఆర్ దేర్? కౌంట్. టోటల్ హౌ మెనీ SLPs ఆర్ దేర్? టోటల్ 4 SLPs. Here 2, here 2. Total 4 SLP. 4 SLP equal to how many ATPs? 4. 1 SLP, 1 ATP. 4 SLP means, సో గ్లైకాలసిస్ అయిపోయేసరికి ఇది సబ్హెడింగ్ పెట్టండి, ఎనర్జీ షీట్ ఆఫ్ గ్లైకాలసిస్. సో ఎండ్ ఆఫ్ గ్లైకాలసిస్ మన దగ్గర ఏమేమి ఉన్నాయి చూడండి. ఎండ్ ఆఫ్ గ్లైకాలసిస్ వీ హ్యావ్ ది వాట్? ఎండ్ ఆఫ్ గ్లైకాలసిస్ వీ హ్యావ్ ది సి 2 molecules of end of the glycolysis we have the 2 molecules of NADPH2 and here 2 SLP, here 2 SLP. అంటే మొత్తం ఎన్నైనా 2 NADPH2, 4 SLP. End of glycolysis. See, we have the 2 molecules of ఏంటి నాన్న? NADPH2. Listen carefully. 1 molecule of NADPH2. బాగినండి. 1 molecule of NADPH2, sometime it produces 3 ATP, sometime it produces 2 ATP. 1 molecule of NADPH2, sometime it produces the 3 ATP, sometime it produces the 2 ATP. When it produces the 3 ATP, when it produces the 2 ATP, and see, if NADH2 synthesized in mitochondria matrix, that time 1 NADPH2 produces 3 ATP. Same NADPH2, if it is produced in cytoplasm, it 1 molecule of NADPH2 produces 2 ATP. Same NADPH2 either produces the 3 or 2. When it produces the 3, when it is synthesized in matrix of mitochondria. When it produces the 2 ATP, when it is synthesized in cytoplasm. And see, 1 molecule of FADH2, always it produces the 2 ATP. Whether it is synthesized in matrix, whether it is synthesized in cytoplasm, wherever it is synthesized. 1 molecule of FADH2 produces 2 ATP. And you know, just now I told 1 substrate level phosphorylation is equals to 1 ATP. Antena? So that enna? So that what is that? Nana? So 1 NADPH2 produces either 3 ATP or 2 ATP. 1 NADPH2 produces 3 ATP when it is synthesized in matrix. 1 NADH2 produces 2 ATP when it is synthesized in cytoplasm. 1 molecule of FADH2 always produces the 2 ATP, and 1 substrate level phosphorylation is equal to 1 ATP. Clear? See, ikkada manaku ఎన్ని NADPH2 ఉన్నాయి చూడండి. This is the glycolysis. End of glycolysis, how many NADPH2 we have? 2 NADPH2. Glycolysis takes place where, Nana? Glycolysis takes place in cytoplasm. Cytoplasm kabatti 1 molecule of NADPH2 produces how many ATP? 2. Kabatti 2 NADPH2, each one produces the 2 ATP. 2 into 2, how many ATPs, Nana? 4 ATP. 2 NADPH2, each one produce the what? 2 NADPH2, each one produce the what? 2 ATP. That's why 2 into 2 Nana? 4 ATPs ga manam cheptam. Clear? And see how many SLPs we have? How many SLPs we have? 4 substrate level phosphorylation. Each substrate level phosphorylation produces 1 ATP. 4 into 1, 4. So total produced ATPs in glycolysis 4 and 4, 8. What is 8, Nana? Total ATP produced in ekkada, Nana? Glycolysis. Okay? And see, listen. In the first reaction 1 ATP consumed. In third reaction 1 ATP. Total how many ATPs consumed? 2 ATPs are consumed. Andala ee 8 lakeli -2 చేస్తున్నాం. Number of ATP consumed ఎంత నానా? Number of ATP consumed 2 ATP. So that 8 minus 2 ఎంత నానా? 6 ATP. 6 ATP is considered as net gain of ATP in case of glycolysis. Net gain of ATP in case of glycolysis. Is it clear? Any doubts? So this is the first reaction in aerobic respiration completed in 4 steps. First one glycolysis. Second one what? Oxidative decarboxylation of pyruvate. Second step ఏంటిదన్నా? What is the second step? In aerobic respiration, second step, oxidative pyruvate ante pyruvic acid. So second step is the oxidative decarboxylation of pyruvate. It takes place in where? Mitochondria matrix. Where it is takes place? It takes place in mitochondria matrix. So ఇప్పుడు మనకు end of glycolysis ఏమున్నాయి నాన్న? End of glycolysis we have 2 molecules of pyruvic acid. దాంతో స్టార్ట్ అవుదాం. Here now we have 2 molecules of what? We have the 2 molecules of pyruvic acid. ఇది బాగిన్నానా? Enzyme name pyruvic dehydrogenase complex. Pyruvic dehydrogenase complex, see, it removes the hydrogen and it removes the CO2. Removal of hydrogen, oxidation. Removal of CO2, decarboxylation. Which enzyme, Nana? Pyruvic dehydrogenase complex. Enzyme name enti, Nana? What is the enzyme name? Pyruvic dehydrogenase complex. Pyruvic dehydrogenase complex removes the hydrogens and CO2 from pyruvic acid and adds the enana coenzyme A. Coenzyme A ను యాడ్ చేస్తుంది, హైడ్రోజన్ను CO2ను రిమూవ్ చేస్తుంది. The two molecules of pyruvic acid is converted into two molecules of enana acetyl coenzyme గా మారుతుంది. Pyruvic dehydrogenase complex. Pyruvic dehydrogenase complex removes the hydrogen and CO2 from pyruvic acid. Result that two molecules of pyruvic acid is converted into two molecules of acetyl coenzyme. See, ఇప్పుడు ఏమేమి రిమూవ్ అయినాయి? హైడ్రోజన్స్ రిమూవ్ అయినాయి, CO. హైడ్రోజన్ రిమూవ్ అయింది కాబట్టి ఆక్సిడేషన్, CO2 రిమూవ్ అయింది కాబట్టి డీకార్బాక్సిలేషన్. See, listen, these removed hydrogens are accepted by NAD plus nana. 2 NAD plus is converted into 2 NADPH2. And how many CO2s are removed? 2 CO2 removed. 1 pyruvic acid nunchi 1 CO2, 2 pyruvic acid nunchi endinana 2 CO2 is removed. So that enana 2 molecules of pyruvic acid is converted into 2 acetyl coenzyme. This reaction is called as oxidative decarboxylation of enana. This reaction is called as oxidative decarboxylation of pyruvate ga manam cheptunnam. Where it is takes place? It takes place in mitochondria matrix lo jarugutundi. Okay na? See, end of oxidative decarboxylation of pyruvate manaki emunnai cheppandi. End of oxidative decarboxylation, we have the two molecules of NADPH2. నేను ఇంతకుముందు చెప్పాను, 1 NADPH2 produces 3 ATP or 2 ATP. When it produces the 2 ATP, when it is synthesized in cytoplasm. Here NADPH2 2, where it is synthesized? It is synthesized in matrix. ఎందుకంటే this reaction takes place in matrix. That's why here one molecule of NADH2 produces how many ATP? In this reaction, 1 molecules of NADPH2 produces matrix kabatti enta nana? Matrix kabatti 1 molecule of NADPH2 produces 3 ATP. Kabatti energy sheet of oxidative decarboxylation manaki emunnai nana? 2 molecules of 1 molecule. Now we have the 2 molecules of NADPH2, each one produces 3 ATP, 2 into 3, 6 ATP. Any ATPs are consumed here? Any ATP consumed in oxidative decarboxylation of pyruvate? Any ATP consumed or not? Tell me. No. But in case of glycolysis, how many ATPs? Here 1 ATP, here. Andukani ikkada em chesanu? Total produced 8, 2 consumed, net gain 6. But in oxidative decarboxylation of pyruvate, there is no consumption of enana, there is no consumption of ATP. That's why 2 NADPH2 we have. 1 NADPH2 produces 3. Endukani 1 NADPH produces 3 enduku? It is synthesized in matrix. That's why 1 molecule of NADPH2 produces 3 ATP. 2 NADPH2 we have. Each one produces the 3 ATP. 2 into 3, 6 ATP. So what is the net gain? What is the net gain are produced in oxidative decarboxylation? 6. So end of glycolysis ennu unnai? End of glycolysis we have the 6, and end of the oxidative decarboxylation 6. 6 plus 6, 12 we have. And what is the third reaction anna? What is the third reaction in aerobic respiration? First one glycolysis, second one oxidative decarboxylation of pyruvate, and third one is the Krebs cycle. So third step, Krebs cycle. This Krebs cycle discovered by the scientist Sir Hans Krebs. This Krebs cycle is discovered by the scientist Sir Hans Krebs. That's why only it is called as, that's why only the cycle is called as Krebs cycle. అర్థమవుతుంది? And see, this Krebs cycle takes place in mitochondria matrix That's why Krebs cycle is also called as mitochondrial respiration also. Glycolysis takes place where, Nana? Glycolysis takes place in cytoplasm. That's why glycolysis is called as what? Cytoplasmic respiration. But here Krebs cycle takes place in mitochondria matrix. That's why Krebs cycle is called as mitochondrial respiration. Sir Hans Krebs discovered. That's why only this cycle is called as Krebs cycle. And it takes place in mitochondria matrix. That's why only it is called as mitochondrial respiration. And see, listen, in case of Krebs cycle point of view, listen, in Krebs cycle, first stable compound, malli chustam idi cycle lo chuddam. First stable organic acid andam. First stable organic acid in Krebs cycle is the citric acid, nana. So what is the first stable organic acid? Which one is formed in the Krebs cycle? Citric acid. That's why only Krebs cycle is also called as citric acid cycle also. First stable organic acid, which one is formed in the Krebs cycle, is citric acid. That's why only Krebs cycle is also called as enana. That's why only citric acid is also called as enana. It is also called as citric acid also. See, citric acid structurally consists of 3 carboxylic groups, nana. Citric acid structurally consists of 3 COOH, means structurally consists of 3 COOH or carboxylic group. That's why it is also, Krebs cycle is also called as tricarboxylic acid cycle, simply TCA cycle antam. Why it is called as TCA cycle? Citric acid structurally consists of 3 carboxylic group. That's why only citric acid is, that's why only Krebs cycle is called as tricarboxylic acid cycle or TCA cycle. See, in case of Krebs cycle, many organic acids are formed, nana. Citric acid, isocitric acid, oxalosuccinic acid, alpha ketoglutaric acid, malic acid, fumaric acid, succinic acid. Different types of organic acids are formed. How we will see? So different types of organic acids are formed in the Krebs cycle. That's why Krebs cycle is also called as organic acid cycle also. Because of enana, different types of organic acids are formed in the Krebs cycle. That's why only Krebs cycle is also called as enana organic acid. Names chala important, nana. Krebs cycle discovered by the scientist Sir Hans Krebs. That's why only the cycle is called as enana Krebs cycle ga manam cheptam. Okay na? Ana. ఒక్క 2 నిమిషాలు ఆగు. నువ్వు ఇటు రాగలుగుతావు అన్న జర ప్లీజ్. ఇట్లాగే జేఎన్టీ మీదకి వెళ్ళిపోదాం, నాకు క్లాస్ అయిపోలేదు, ఇక్కడనే ఉన్నా. రైట్. So that enana, so Krebs cycle discovered by Sir Hans Krebs. That's why only it is called as Krebs cycle. It is discovered by takes place in mitochondria matrix. That's why it is called as mitochondrial respiration. And first formed organic acid, citric acid. That's why citric acid cycle. Citric acid structurally consists of 3 carboxylic group. That's why only it is called as TCA cycle. Many organic acids are formed. Many organic acids are formed. That's why only the cycle is called as organic acid cycle ga manam cheptam. Aerobic respiration completed in how many steps, nana? Aerobic respiration is also called as what? Aerobic respiration is also called as what? Cellular respiration. What is aerobic respiration? Tell me. What is aerobic respiration? The respiration which is occurred in the presence of oxygen. In the absence of oxygen, anaerobic respiration. So 686 kilocalories of energy synthesized in, it is produced in aerobic. In anaerobic, how many? 56 kilocalories of energy. Ethyl alcohol is the product of aerobic or anaerobic? Ethyl alcohol, C2H5OH, edundi C2H5OH. Aerobic respiration completed in how many steps? Aerobic respiration completed in how many steps? 4 steps, which include glycolysis, oxidative decarboxylation, and Krebs cycle and where electron transport system takes place. Where electron transport system takes place? It is takes place in mitochondria cristae. What is cristae? What is folding? Inner membrane shows folding. That foldings are called as cristae. On the surface of cristae, for example, this is the cristae. On the surface of cristae, a numerous pin-like structures are present. They are called as, earlier it is called as oxysome. Nowadays it is called as F0 and F1 particle. What is the function? What is the function of F0 and F1? F0 and F1 plays an important role in the synthesis of ATP. అందుకనే F0 and F1 మనము ATP ase enzyme గా అని కూడా చెప్తాం నేను. F0 and F1 both collectively called as F0 and F1. Earlier it is called as oxysome. Now we are not using that term. That F0 and F1 plays an important role in the synthesis of ATP. That's why F0 and F1 is considered as the ATPase. ఎందుకని ఇవి synthesize the ATP కాబట్టి it is considered as the ATPase enzyme. And one thing, one molecule of ATP on hydrolysis process, it produces 7.6 kilocalories of energy. One molecule of ATP on hydrolysis process, it would releases 7.6 kilocalories of energy. ATP is the example of what anante? It is the example of nucleotide nana. ATP is the example of what nana? Nucleotide. ATP is the example of what nana? ATP is the example of what? It is the example of what? It is the example of nucleotide ga manam cheptam. So enduku nucleotide? Adenosine triphosphate. Phosphate undi kabatti nucleotide. What is nucleotide nana? What is nucleotide? ATP is the example of nucleotide. What is nucleotide? ఇవి రాకుండా మీరు న్యూమరికల్ చేయడం కష్టం. న్యూక్లియోటైడ్ ఈక్వల్ టు గుడ్ 1 nitrogen base, 1 sugar and 1 phosphate molecule. Instead of phosphate, phosphoric acid is also correct. And between the nitrogen base and sugar, what is the bond is present? The bond which is present between nitrogen base and sugar, biomolecules lo cheppa. What is the bond is present sir ante? Glycosidic bond. The bond which is present between the sugar and phosphate, what is that bond sir ante? Ester bond. అందుకే న్యూక్లియోటైడ్లో ఉండే బాండ్స్ ఏవని చెప్తాం నాన్న? గ్లైకోసైడిక్ బాండ్ అండ్ ఎస్టర్ బాండ్గా మనం చెప్తాం. సో ATP on hydrolysis process, 1 molecule of ATP would release the 7.6 kilocalories of energy. ATP is the best example of nucleotide. Nucleotide equal to 1 nitrogen base, 1 sugar and 1 phosphate. అందుకే in 1 nucleotide, 1 nitrogen base, 1 sugar, 1 phosphate. That's why the ratio of nitrogen base, sugar and phosphate ante emani cheptamu? 1:1:1. The ratio of nitrogen base, sugar and phosphate in nucleotide ante 1:1:1 ga manam cheptam. And between the nitrogen base and sugar, which bond is present? Between the nitrogen base and sugar, glycosidic. Like that, between the sugar and phosphate, ester bond is present. Okay na? And this Krebs cycle, Here Krebs cycle is also completed in 10 steps, Nana. Krebs cycle is all. Glycolysis is completed in how many steps? 10 steps. See, 1, 2, 3, you go 4, this is 5, this is 6, 7, 8, 9, 10. So glycolysis is completed in 10 steps. Like that, Nana, Krebs cycle is also completed in 10 steps. In every step, organic acid is formed, Nana. Every step, in first, second, third, fourth, like that, in every step, organic acid, for example, citric acid to cis-aconitic acid, isocitric acid, alpha-ketoglutarate acid, succinyl coenzyme A, succinic acid, fumaric acid, malic acid, oxaloacetic acid, different, in every step one organic acid is formed. That's why different types of organic acids are formed in the Krebs cycle. That's why Krebs cycle is considered as the what? Organic acid cycle ga manam cheptam. Okay na? Continue, we'll see tomorrow. Okay na? ఇలా కొంచెం లేట్ అయిపోయింది, మధ్యలోకి వస్తుంటే పెట్రోల్ అయిపోయింది.